Let's see some very basic questions, but very concept building questions on discrete signals. The question is, let xn equal to 0 for n less than minus 2 and n greater than 4. That is, if this is n less than minus 2. So, minus 2, minus 1, 0, 1, 2, 3, 4. So, the question says that xn, whatever be this signal, maybe this is the signal, just say, let's suppose this is the signal, but below this it is 0, minus 3, minus 4 or above 4. So, this is the signal. It says determine the values of n for which this signal is 0, x n minus 3 is equal to 0. So, how we will find? See, the way to find this is x n is equal to 0 for n less than minus 2 and n less than n greater than 4. So, this will be n minus 3 will be 0 for, we'll replace n by n minus 3 here, n minus 3 less than minus 2 and n minus 3 greater than 4. What is this? N minus 3, if when it goes to this side, this will be n will be less than 3 minus 2 and n greater than 4 plus 3. So, what do you get finally? N less than 3 minus 2, 1 and n greater than 7. So, this signal will be equal to 0 for n less than 1 or n greater than 7. Okay. This is how we find x n is equal to 0 for this value of these values of n. Now, what is for n plus 4? N plus 4 will be 0 for, on similar terms, what we will do? N plus 4 will replace n by n plus 4 less than minus 2 and n plus 4 greater than 4. So, this comes to 4 goes to this side, it is minus. So, n less than minus 6 and n this side 0. So, n greater than 0. This is for the second one. Okay. Now, the third one. How do we handle minus values when n is minus? Very easy. X minus will be 0. We'll simply replace this by minus n. Minus n is less than minus 2 and minus n is greater than 4. What do we do in inequality when we have minus? We multiply it with minus 1 and the inequality is reverse. So, this becomes, when we multiply this by minus 1, this becomes n and this becomes 2. This is less than, this becomes greater than. And this side minus becomes n and this becomes minus 4 and greater becomes less than. So, it is for n greater than 2 and n less than minus 4. Okay. Do one more example so that everything is clear. Next is x minus n plus 2. This will be 0 for minus n plus 2 less than minus 2 and minus n plus 2 greater than 4. This is, if you take this to this side, this will be minus n less than minus 4 and minus n greater than 4 minus 2, that is 2. Now, multiply it with minus. So, you will get n, this is less. So, this will be greater than 4 and this side minus. So, n greater than becomes less than. So, n less than minus 2. So, this is the condition. So, for these values of n, these functions will be 0. Okay. Now, the question is xt is equal to 0 for t less than 3. We have to find what will be the value of t for which x1 minus t is equal to 0. x1 minus t equal to 0 is equal to 0. In the last example, we had seen discrete signals. This is for continuous signals. So, we will do in similar way. What we will do? We will put 1 minus t in place of t. So, this means minus t is less than 3 minus 1, that is 2. Or if you multiply this with minus 1, what you get? You get t and here you get minus 2 and this less than equal to, less than sign becomes greater than sign. So, we have this, so we have this for this value, that is x1 minus t will be equal to 0 for t greater than minus 2. Here only what we do, let's see the second question, x2 minus t. Very similar to this, it's 2 minus t less than 3. So, minus t is less than 1. This means t greater than minus 1. Okay. So, this is for t greater than minus 1. Now, the third one, that third and fourth question, That is to be understood. It says for what value this signal plus this signal x1 minus t plus x2 minus t will be 0. Now here this is or this signal. Now we know this signal, for this signal this value will be 0 for t greater than minus 2 and for this t greater than minus 1, that is this is greater than minus 2, this is greater than minus 1. If we plot like this, minus 2, minus 1, 0, 1, so on. Now this x1 minus t, this signal greater than minus 2. So whatever be this signal is 0 after this and this signal is 0 after this. It is like this and this is like this. We have to see that this is equal to 0. This plus this combined signal is 0. So obviously after this only this combined signal is 0. Here we will have some value. If we take between minus 1 and minus 2, we will have some values. But after minus 1, this plus this will be 0 undoubtedly. So answer will be t greater than minus 1. So for t greater than minus, this combined signal will be 0. And what if these two are in AND operation? That is x1 minus t into x2 minus t. Now this will be 0 when this, either this or this is 0. This is for x greater than minus 2 and this is for x greater than minus 1. Now even if we talk of this region minus 1 to minus 2, this signal will be 0 and when this signal will be 0 multiplied to this will be 0. So here what we will have? X greater than minus 2, sorry, t greater than minus 2. So for t greater than minus 2, this product will be 0. Okay, clear? Now next question. If we have some scalar multiplied to the t variable, xkt equal to 0 we have to find. Very simple, we will replace it by this. So this will be t greater less than 3 by 4, not 4, k, 3 by k. So for t less than 3 by k, this will be 0. Okay. Determine whether the following signals are periodic. You know what is a periodic signal? If a signal xt repeats after this time period, that is this becomes this, we say it is periodic with frequency time period t. And in discrete signal, we say if this is the case, we say this is your period. The smallest value of n or t will be fundamental time period. Okay, so we have to determine the first signal is xt equal to 2 e j t plus pi by 4 ut. Let's understand this. Ut means it is 0 for t less than 0 and 1 for t greater than equal to 0. This is ut. So whatever be this signal, even if this signal is very periodic, this signal does not exist below 0. If this is t timeline, so the value of this signal is 0 for t less than 0. This is clear because it is multiplied by ut. So here this whole side, it is the value of the signal is 0. So even if it is periodic to this side, it is not periodic. The whole signal is not periodic. This side is completely 0. Therefore, this signal is not periodic. Not periodic. Clear? So let's see the second one. Un plus u minus n. What is this? This is unit step function. So you know about unit step function that un is equal to 0 for n less than 0 and it is 1 for n greater than 0, greater than equal to 0. This is unit step function. So if you see on this line 0, if this is 0, you'll have these values. Okay, 1, 2, 3 and so on, 1, 1, 1, 1. Okay, so this will be like this. What about this signal u minus n? So minus n, this will be reversed. So this will be 0 for n greater than 0 and it will be 1 for n less than equal to 0. Okay, so this signal will be like, this is your un and this will be less than equal to 0, it is 1. So if this is 0, it is 1, minus 1, it is 1, minus 2, it is 1. Okay, and these 1, 2, 3, these will be 0. So this signal is u minus n. Now when you add these two signals, this plus this, what will happen? The resultant signal will be, let's say this is 1, 1, 1, 1. This is minus 1, this is minus 2, this is minus 3, minus 4. Leave 0, go to again 1. It will be 1, 1, 1 and so on. Okay. What about at 0? At 0, you have 1 from here. This value will be 1 and this is also 1. So 1 plus 1, 2. So at 0, the value will be 2. So everywhere for n less than 0 and everywhere for n greater than 0, the value of the signal is 1 only. But at n equal to 0, the value is 2. So this is not periodic. Okay. If this was also 1, this would have been a periodic signal, but because of this, it is not periodic. Okay. Now let's see our third question. The first signal is k equal to minus infinity to infinity del n minus 4k. Okay. So what will be this signal? We'll have the second part. This is minus this. First of all, let's see what is this part. Del n minus 4k. Let's say at k equal to 0, what will be the value of this signal? This will be equal to whatever we put the name of this part. So this part will be equal to, when k is equal to 0, it will be equal to del n. And since this is 1, so this will be an impulse of at n equal to 0. Okay, so let's draw it here. That is here. At k equal to 1, this will be equal to n minus 4. Similarly, at k equal to 2, n minus 8. What about at minus 1? At k equal to minus 1, this will be, see, minus 1. So n plus 4. Okay. And at k equal to minus 2, this will be equal to del n plus 8. Okay. So this signal will be like this. At 0, you have value. Then you have value at 4. So let's say 1, 2, 3, 4. Then 5, 6, 7, 8. So these are for 8 and 4. And then this side is, see, n minus 4. So this is shifted to this, n minus 8. Similarly, you have at minus 4 and minus 8. Okay. So you have impulses at these points. This is the first signal. What about the second signal? The second signal is minus of n minus 1 minus 4k. That is, this is n minus 1. So again we will see at k equal to 0, this will be equal to del n minus 1. That is, and this is minus, see, this is minus. So this will be 0. So if this is 1, it is k equal to 1. This will be minus n minus, see, this is 1. So minus 1 and minus 4. So minus 5. So this will be at, see, 0 to 4, you have this point, then 5 again, minus 1. This is at 1, this is at 5. Then obviously at 9, this will be minus 1. This side, that is k equal to minus 1, this will be equal to minus of, k is minus 1. So this will be minus 1 plus 4. So this will be, okay, n plus 3. That is shifted to this side at minus 3. Then similarly, this way 8 minus 1, 7. That is at minus 7. You will have value minus 1. So this signal is like this, the second one signal. So if this plus this, you do this plus this, what you will get? You will get at 0, if this is 0, you will get this value. That is, this is 0. That's a 1, 2, 3, 4, 5, 6, 7, 8. So this is the first signal. This is 4, this is 8. Similarly, minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7, minus 8. Okay, minus 8, minus 4. So this is the first signal, and second signal will be superimposed here. This is at minus 1, then at minus 5, sorry, not minus 5, 5, minus 1, this is 1, 1, 1, 1, 1, you at minus 7, you at minus 3. So this will be the resultant signal. Is it periodic? See, 0, at 0 this is 1, at 1 it is minus 1. So 0, 1, 2, 3, again at 4, 1, minus 4. So what you have? 1, 2, 3, 4. So it is periodic. Every fifth, 1 to 4, 5 to 8. Now signals are periodic. They are repeating it themselves. And the fundamental frequency is 4. So this signal is periodic with fundamental frequency n equal to 4. Clear? You can see this is repeating itself. Okay.